Tomorrow morning, while most of the world sleeps, a ring of fire will ignite over the frozen wastes of Antarctica, signaling the start of a 14-day window that geophysicists are watching with unusual intensity. February 17th, 2026. A date most people have marked on their calendars merely as a Tuesday. But for those of us who monitor the deep rhythms of the Earth, this date represents the opening of a massive gravitational door. At 12:13 Coordinated Universal Time, the Moon will pass directly in front of the Sun. Because the Moon is currently near the farthest point in its orbit, it will not cover the solar disk completely. Instead, it will obscure exactly 96% of the star, leaving a brilliant blazing annulus, a ring of fire, hanging in the sky above the South Pole. The visual spectacle will be reserved for the penguins and the handful of researchers shivering at remote bases like Amundsen Scott or Vostok. For the rest of the planet, particularly in southern Africa and the southern tips of South America, it will manifest as a subtle, eerie dimming of the daylight. But to focus on the shadow is to miss the point entirely. The shadow is merely the clock face. The gears turning behind it are what matter. This eclipse marks the precise moment when the Sun, the Moon, and the Earth lock into a straight line. This is a syzygy, an alignment of three celestial bodies that combines their gravitational pulls into a singular, directed vector. When this happens, the planet we stand on does not just sit there. It stretches. It responds. The solid crust of the Earth, which we like to imagine as immovable stone, will rise and fall by several centimeters under the combined weight of the Sun and the Moon. The oceans will bulge, driving the spring tides to their highest maximums. And deep underground, in the hairline fractures of tectonic faults that are already locked under centuries of strain, the pressure will shift. We are covering this story deeply today because we are entering a specific 2-week corridor. It begins tomorrow with this solar eclipse, and it ends 14 days from now, on the night of March 2nd and 3rd, with a total lunar eclipse. This is not astrology. This is physics. And before we go any further into the data that connects these alignments to the movement of continents, I want to invite you to subscribe to this channel if you value analysis that looks past the headlines and into the mechanisms driving our world. If you want to understand the science of the Earth system as it happens, hit that subscribe button now, so you do not miss the updates coming in this critical 14-day window. The skepticism around this topic is usually high, and rightly so. For decades, the idea that the Moon could trigger earthquakes was dismissed as folklore. But in the last 10 years, the scientific consensus has quietly shifted. We are no longer asking if the tides affect the crust. We are asking how much and when. The alignment tomorrow creates a condition geophysicists call peak tidal stress. It is a moment when the gravitational tug-of-war is not canceling itself out, but pulling in unison. Imagine a rubber band stretched almost to its breaking point. That is a tectonic fault line in a subduction zone. It holds vast amounts of potential energy, waiting to snap. Now imagine someone gently blowing on that rubber band. That breath of air is the tidal force. In isolation, the breath is nothing. It is too weak to break a rubber band. But if that band is already microscopically close to failure, that tiny extra input, that invisible nudge, can be the final joule of energy that dictates the timing of the rupture. This is the context for tomorrow. We are not predicting a catastrophe. We are observing a mechanism. The ring of fire over Antarctica is the visual confirmation that the gravitational mechanism is currently active. The Earth is entering a phase of heightened sensitivity. As the moon's shadow races across the ice at thousands of kilometers per hour, the rock beneath the ice, and indeed the rock beneath all of us, is feeling the pull. The question is not whether the Earth is being squeezed. The question is whether there are any faults currently poised at that critical threshold where the squeeze matters. Scientific history is full of coincidences until they are proven to be correlations. As we move into this fortnight of alignment, we need to understand exactly what the data tells us about previous windows like this. We need to look at the numbers that define the physical stress, and we need to look at the history of megaquakes that have strangely clustered around these dates. The alignment is silent. You will not feel it. You cannot see the gravity wave passing through the mantle, but the seismographs can, and right now they are the most important instruments on the planet. As we stare at the images of the blackened sun that will emerge tomorrow from the Antarctic feeds, remember that you are seeing a heavy weight being placed on the scale of the Earth. The eclipse is the signal. The response, if there is one, comes from the ground. In the next section, we are going to look exactly at how heavy that weight is and why a study from 2016 changed everything we thought we knew about the timing of the world's biggest disasters. We will break down the kilopascals, the stress rates, and the terrifying precision of the lunar trigger. Stay with me. The mechanism is just beginning to turn. As we established, the solar eclipse over Antarctica is effectively a celestial dial indicating that gravitational forces are reaching their zenith. But to understand why this matters to the ground beneath our feet, we have to strip away the mysticism and look at the raw physics of tidal loading. When the sun, Earth, and moon align, as they are doing right now, the gravitational pull is not just a vague concept. It is a measurable physical force that exerts pressure on every square meter of the planet. We often think of tides only in terms of the ocean, water sloshing up a beach, but the solid Earth has tides too. The stone crust of our planet is elastic. Under the influence of this alignment, the ground you are standing on right now rises and falls by roughly 30 to 40 centimeters every day. You do not feel it because everything around you is moving with it. But to a fault line deep underground, this movement is everything. The stress applied to tectonic faults during these periods shifts by roughly 1 to 4 kilopascals. To put that number in perspective, the stress released during a typical earthquake is millions of times greater. A drop of 4 kilopascals in the ocean of tectonic forces seems laughable. It is roughly equivalent to the pressure of a handshake. For years, seismologists argued that such a tiny fluctuation could not possibly trigger a massive rupture. And they were right, for 99% of cases. But they were missing the edge cases. They were missing the faults that were already locked, loaded, and trembling on the very edge of failure. The most widely cited evidence for this mechanism appeared in the journal Nature Geoscience in 2016, and it fundamentally altered the conversation. A team led by Japanese seismologist Satoshi Ide conducted a rigorous statistical review of the largest earthquakes of the 20th and 21st centuries. They were looking specifically at events with a magnitude of 8.2 and above. The true monsters. What they found was chilling in its simplicity. They examined 12 of these megaquakes. They found that 9 of them struck on days of maximum tidal stress, days exactly like the one we are entering tomorrow. Days near the new moon or the full moon. The correlation was not vague. It was sharp. The massive earthquake that devastated Sumatra in 2004, a magnitude 9.1 event, occurred near a full moon. The magnitude 8.8 in Chile in 2010 happened near a full moon. The catastrophic Tohoku earthquake in Japan in 2011, a magnitude 9.0, struck near the new moon. The pattern was impossible to ignore. Ide and his team demonstrated that the probability of a small earthquake growing into a giant one increases statistically during these periods of high tidal loading. Note the distinction here. The tides do not create the earthquake. The tectonic plate motion does that. But the tides seem to act as a lubricant or a final nudge. If a small fracture begins on a day with low tidal stress, the friction of the fault might stop it after a few seconds. It remains a minor tremor, unnoticed by anyone but the sensors. But if that same fracture begins on a day like tomorrow, when the crust is being stretched and the clamping forces on the fault are slightly reduced, the rupture does not stop. It runs. It cascades. It grows from a magnitude 5 to a magnitude 7, and then to a 9. The authors of the updated study calculated that while this effect is tiny, influencing perhaps only 1 in 10,000 seismic events, it is disproportionately present in the largest, most dangerous ruptures. The great subduction zones, where one tectonic plate dives beneath another, seem particularly sensitive to this cosmic rhythm. These zones accumulate strain for decades or centuries. They sit there, silent and locked, building up energy. When they are finally ready to go, they do not need a sledgehammer to set them off. They just need a whisper. This is why the double alignment we are facing this month is so critical. We have the solar eclipse tomorrow, creating one peak of stress. Then, exactly 14 days later, we have the total lunar eclipse, creating a second, even stronger peak. This is a rhythmic pumping of the Earth's crust. Stretch and release, stretch and release. For a fault line that is teetering on the brink calculation, this 14-day window is a stress test. It is important to visualize this correctly. Do not picture the moon ripping the Earth apart. Picture a vast, silent library filled with precarious stacks of books. The tectonic strain is the height of the stacks. They are wobbling, ready to fall. The tidal force of the eclipse is not someone pushing the books over. It is a heavy truck driving past the building. It is a subtle vibration, a background wave. Most of the stacks will stand firm, but the one stack that was already leaning, the one that was 1 second away from collapse, that is the one that falls. We have established the gravitational trigger. It is real, it is documented in top-tier journals, and it is active right now. But gravity is not the only invisible force washing over the planet this week. While the moon pulls on the rock from one side, the sun is throwing something else at us from the other. New research suggests that the magnetic environment of the Earth might be just as important as the gravitational one. And right now, the space weather forecast is looking just as volatile as the tidal charts. We need to talk about solar wind, proton density, and the strange electrical link to seismicity that science is just beginning to uncover. Building on the gravitational framework we have just laid out, we arrive at the second, and perhaps even more controversial, layer of this story. If the tides are the mechanical nudge, then the solar wind might be the electrical trigger. For a long time, the idea that activity on the sun could influence earthquakes on Earth was relegated to the fringes of science. It sounded too much like science fiction. But just like with tidal stress, the data has recently forced the mainstream scientific community to take a second look. While the moon is physically stretching the crust tomorrow, the sun is doing something else. It is bombarding us with a stream of charged particles. This is the solar wind. And in 2020, Italian researchers publishing in Scientific Reports, a journal under the Nature umbrella, dropped a bombshell. They established a statistically significant correlation between the density of protons in the solar wind and the occurrence of large earthquakes worldwide. They looked at data covering 20 years. They specifically focused on earthquakes with a magnitude greater than 5.6. What they found was a spike in seismic activity that consistently followed peaks in solar proton density, with a lag of just 1 day. This implies that when the Earth is buffeted by a dense stream of solar particles, something in the crust responds 24 hours later. Then, more recently in 2025, a paper in Geophysical Research Letters took this a step further. They used a sophisticated statistical technique called shift neighborhood matching correlation to link strong geomagnetic storms with global seismic activity. They were trying to see if the shaking of the Earth's magnetic field, which happens when a solar storm hits, could translate into the shaking of the ground. Their results suggested a link that could not be dismissed as random chance. The mechanism here is different from the tidal squeeze. The leading theory is piezoelectricity. Many crystals in the Earth's crust, like quartz, are piezoelectric. This means that if you squeeze them, they generate an electric charge. But the reverse is also true. If you apply a strong electromagnetic field to them, they can vibrate or change shape slightly. The theory proposes that as a geomagnetic storm rattles the Earth's magnetosphere, it induces electrical currents in the ground. These are known as geomagnetically induced currents. We know they exist. They can blow out power grids and corrode pipelines. The hypothesis is that these currents might also lubricate faults. Imagine that same locked fault line we discussed earlier. It is held together by friction, but friction is, at the atomic level, an electrical phenomenon. It is the bond between atoms on one side of the rock and atoms on the other. If you surge a current through that rock, you might alter the electrical state of those bonds. You might, effectively, grease the fault with electricity. This brings us to the concept of resonance. A single tap on a glass might not break it. A single gust of wind might not bridge a gap. But if you have gravity pulling the crust up and down, and simultaneously you have electromagnetic currents vibrating the fault from the inside, you create a compound effect. The tidal force provides the mechanical stress. The solar storm provides the electrical unbinding. This is the cosmic resonance we are talking about. It is not a mystical harmony. It is the superposition of two physical waves, a gravitational wave from the moon and an electromagnetic wave from the sun. When they peak at the same time, the Earth is subjected to a unique set of stresses. Right now, we are in a position to test this resonance in real time. We have the eclipse alignment providing the gravitational peak. Do we have the solar component? Yes, we do. And this is where the situation becomes immediate. We are not looking at historical data anymore. We are looking at the monitors right now. Before we jump into the specific forecast for the next 24 hours, I want to hear from you. Do you think this connection between solar activity and earthquakes is something we should be funding more research into? Or do you think it is still too speculative? Leave a comment below with your thoughts on the electric earthquake theory. I read the comments to gauge what deep dives we should tackle next. We have the mechanism. We have the two studies from Nature and Geophysical Research letters backing it up. Now we need to look at the dashboard. What is the sun doing at this exact moment? The data coming in from the solar observatories shows a large coronal hole facing Earth. This is a gap in the sun's magnetic field that acts like a nozzle, spraying high-speed solar wind directly at us. That stream is arriving now. Combined with the tidal peak of the eclipse, we are seeing the exact overlapping conditions that those researchers warned us about. In the next chapter, we are going to look at the specific warnings issued for the coming hours and the strange cluster of seismic events that has already begun to tick up in the southern hemisphere. The experiment is running. Given what we now understand about the dual triggers of tidal stress and solar wind, the current planetary status board takes on a much more serious tone. We are not dealing with hypothetical scenarios. We are dealing with real-time data that looks almost perfectly aligned with the high-risk criteria identified in the scientific literature. Right now, a massive coronal hole is open on the stellar surface. It is Earth-facing. The stream of high-speed particles from this dark chasm is currently buffeting our magnetosphere. Space weather forecasting centers have issued alerts for G1 to G2 class geomagnetic disturbances expected in the coming hours. This is not a catastrophic solar storm, but it is a significant elevation of the background energy. It creates exactly the kind of proton density spike that the 2020 study correlated with seismic activity. So, we have the gravitational key turning in the lock with tomorrow's Ring of Fire eclipse, and simultaneously, we have the solar wind pushing on the door with a G2 geomagnetic storm. The conditions for resonance are active. The question is the Earth responding? If we look at the seismic feeds from the last 48 to 72 hours, the answer seems to be a tentative yes. We are seeing a cluster of moderate to strong activity specifically along the Pacific Ring of Fire, which is exactly where the tidal loading effect is supposed to be most pronounced. Just recently, Vanuatu was shaken by a magnitude 6.4 earthquake. This is a classic subduction zone event deep in the trench where the Australian plate dives under the Pacific plate. Almost simultaneously, on the other side of the ocean, Chile registered a magnitude 6.2. Chile, as you recall, was one of the locations of the megaquakes cited in the Satoshi ID study. The crust there is perennially loaded, always waiting for a trigger. Perhaps even more visually arresting is the fresh activity at Mount Semeru in Indonesia. This volcano has erupted again within the past few days, sending ash plumes high into the atmosphere. Volcanic systems are hydraulic systems. They are chambers of pressurized fluid. They are incredibly sensitive to squeezing. When the solid earth tide compresses the magma chamber, it can force the liquid rock upward, just like squeezing a tube of toothpaste. The timing of Semeru's wakening, right as we enter the eclipse window, is a data point that fits the model. It would be irresponsible to say these events were definitely caused by the approaching eclipse. Earthquakes and eruptions happen every day. It could be simple coincidence. We are at the tail end of a solar maximum, so the natural background of solar activity is high. The tectonic plates never stop moving. Random clusters of magnitude 6 earthquakes are statistically common. But this is where the analytical mind must balance skepticism with pattern recognition. We have a mechanism, tidal stress. We have a secondary mechanism, geomagnetic shifts. We have a prediction that these forces increase the probability of ruptures. And we have an observation, a sudden uptick in ring of fire activity exactly as the forces align. It acts as a smoke signal. It tells us that the system is dynamic. The events in Vanuatu, Chile, and Indonesia are likely purely tectonic in origin, but they indicate that those specific fault zones are critical. They are active. They are moving. If there is a massive fault segment adjacent to the one that just broke in Vanuatu, and it is locked, the stress transfer from the 6.4 combined with the tidal peak tomorrow could be the final straw. This is the shift neighborhood matching mentioned in the research. It is not about a global catastrophe where the whole world shakes at once. It is about specific, localized neighborhoods of stress. The eclipse puts a magnifying glass on these neighborhoods. The alignment tomorrow is only the opening act. It is the start of the squeeze. The pressure will not alleviate once the shadow passes Antarctica. The moon continues its orbit. The geometry continues to evolve. We are moving toward the second act of this drama, which occurs in 2 weeks. If the solar eclipse is the inhalation, the lunar eclipse on March 3rd is the exhalation. And historically, the release can be just as potent as the squeeze. As we watch the seismographs in Chile and Japan over the next 24 hours, we are gathering data points for a hypothesis that gets stronger with every correlation. But the corridor does not close tomorrow. It opens, and at the end of the hallway stands the blood moon. In our final chapter, we will look at what that second peak implies and how scientists are using these rare moments not to panic, but to learn the deepest secrets of our living planet. This brings us to the future. If tomorrow's solar eclipse is the signal to start watching, then the total lunar eclipse on March 3rd is the culmination of the experiment. Exactly 14 days from now, the geometry will flip. Instead of the moon passing between us and the sun, the Earth will pass between the sun and the moon. On the night of March 2nd and 3rd, the Earth's shadow will swallow the satellite completely. It will turn a deep, rusted red, the phenomenon known colloquially as a blood moon. This color comes from sunlight filtering through Earth's atmosphere, with all the blue light scattered away, leaving only the red wavelengths to be bent onto the lunar surface. It is, vividly, a projection of all the sunsets and sunrises of the world simultaneously cast onto the moon. But while the poets look at the light, the geophysicists will be looking at the gravity. This moment represents the second peak of tidal stress in this corridor. At the full moon, the sun and moon are on opposite sides of the Earth, pulling in opposite directions. This stretches the planet just as intensely as when they are on the same side. The crust is elongated. The faults are pulled taut. If the ring of fire tomorrow is the primer, the blood moon is the detonator. The 14 days between these two events are a continuous period of heightened strain. Any fault that was destabilized but not ruptured during the solar eclipse may find its breaking point during the lunar eclipse. The stress accumulates. It migrates. Researchers already treat these moments as a natural laboratory. They are not running for the hills. They are calibrating their instruments. The color of the blood moon itself provides data on the state of Earth's stratosphere. How much volcanic ash or aerosol pollution is currently suspended up there. Meanwhile, seismologists will track how the microseismic background shifts. They are looking for tremors, tiny, non-earthquake vibrations that indicate deep slow-slip events. These often precede major ruptures, and they are highly sensitive to tidal modulation. It is crucial to frame this correctly. No one is predicting a guaranteed catastrophe. The vast majority of earthquakes remain purely tectonic, driven by the slow, grinding convection of the mantle that has been happening for billions of years. The stars do not dictate our fate, but they do influence the timing. During these windows, the eclipse corridors, the statistical risk of that tiny extra nudge on a stressed fault is measurably higher. The probabilities shift from 1 in 10,000 to perhaps 1 in 1,000. It is still a low probability for any single location, but when you apply that shift to the entire Pacific Ring of Fire, the aggregate risk becomes significant. The cosmos does not stage dramas for our benefit. It simply follows its own laws. We are part of that vast system. We live on a cooling rock that is spinning in a gravity well, bombarded by solar particles, and tugged at by a cold, gray satellite. Most of the time, we can ignore these forces. We build our cities and live our lives assuming the ground is solid. But tomorrow's ring of fire above Antarctica and March's blood moon are a rare occasion when those ancient celestial rhythms become both visible and measurable. They force us to look up and then, immediately, to look down. They remind us that the Earth is not a static stage, but a dynamic participant in the solar system. So, in the coming days, if you see a headline about a quake in the Pacific or a flare on the sun, you will know the context. You will know it is not just a random roll of the dice. It is part of the brave, beautiful, and sometimes terrifying physics of the world we live in. Worth watching, if only out of curiosity. Sometimes the faintest cosmic touch reminds us how thin the line is between the stillness of the ground beneath our feet and the next movement of the Earth. Thank you for joining me on this investigation. If you found this balanced, data-driven approach valuable, please hit that like button. It helps the algorithm share scientific literacy with a broader audience. Stay curious, stay observant, and I will see you in the next deep dive.